Hi everyone, we're going to go ahead and work a couple example problems, one on density and one on pressure. If you're having problems, hopefully this clears them up. What is the mass of a solid iron wrecking ball of radius 18 centimeters? So we're supposed to find mass, question mark. We're given its iron, that's important, and it has a radius of 18 centimeters. Alright, now density is an intrinsic characteristic property of matter. Every element has its own specific density. So we can just go to a table of densities and we can look up the density of iron. Iron, if I just do a quick Google search for the density of iron, I see that it is 7.874 grams per cubic centimeter. 7.874 grams per cubic centimeter. Okay. Now, we're given a radius, we have a density, and we're asked to find mass. Well, this is a density problem, but since it's a wrecking ball, a ball is a sphere, we'll assume it's a sphere, and the volume of a sphere is equal to 4/3 pi times the radius cubed. So that's actually enough information for me to find the volume of the sphere, and since I know that density is equal to mass over volume, I need two of those three things, and so I can say mass is equal to density times volume. So if I can find the volume, I know the density will be good to go. So I'm just going to say M equals 7.874 grams per cubic centimeter times its volume. Now since this is in cubic centimeters and this is in centimeters, I'm not going to change anything to meters. It'll be okay. So times 4/3 pi times 18 cubed. I'm just going to run that in my calculator real quick. 7.874 times 4 divided by 3 times pi times 18 cubed. 192,354. Okay. 192,354. This is going to be in grams because my cubic centimeters here are going to cancel my cubic centimeters there. The only thing left is grams. That's a fairly large amount of grams, so we might write this as 192.35 for kilograms. Okay. Either of those are acceptable. Next question is a pressure problem. It says, the 2 feet of a 60 kilogram person cover an area of 500 square centimeters. Determine the pressure exerted by his 2 feet on the ground and what the pressure will be if the person stands on 1 foot. We'll recall pressure is equal to force divided by area. It's the result of a force acting over an area. So we need a force, but we don't have one. We're told a mass, 60 kilograms. But that mass causes a weight, so we can find his weight, which will be the force, F equals mg, so 60 times 9.8 meters per second will give us the force he's applying on the ground, which is 588 newtons. Okay. So our 588 newton force is spread over 500 square centimeters, so pressure is force, 588, divided by area, 500 square centimeters. This is newtons, centimeters squared, so divided by 500 and we get 1.176 newtons per square centimeter. This is not a standard unit of pressure. It's not a Pascal. A Pascal is a newton per square meter, but it is a unit of pressure, so we can leave it like that. Now it says determine the pressure if he stands on 1 foot. Well, he's still going to exert the same amount of force because that doesn't change his weight, but he's only going to exert it over half the area. So there's two ways of looking at this. You could say 588 over 250 square centimeters and get 2.352 newtons per square centimeter. Or you could go, well, we're having the area which is going to double the pressure. So you could just take this number times 2 and also get 2.352 newtons per square centimeter. Okay. So these problems are pretty straightforward. The thing to remember is you've got to keep track of units and remember mass is not weight.